So let's start. Okay. What we will do today, we'll first complete the theory portion, very interesting. And once we are done with the theory, then we'll take up problem. Problems are very, very easy in this chapter. Okay. So let's start with pressure. So the prelude to understand pressure is that you should understand what is force, and you very well have an idea of what is force. Okay. Now let's get first of all our basics correct. So let me use the draft. It will be faster with this. Because what I'm going to draw, based on that, you'll get some problems also. Right. So this be a cuboid. Right, this be a cuboid, and right now try to concentrate on the top surface, and I'm naming the top surface as say ABCD. Have you understood? Cuboid is characterized by three measurements. This would be the length, this would be the width, and this is the height. So what does the top surface look to you like? A rectangle, right? And area of the rectangle for the top surface would be this particular length into this width. So L into W will give me the area of the rectangle. Now we need to understand what is pressure. So in many books you'll see pressure is written as force per unit area. That's exact definition. If you want to go by the pure mechanical engineering definition, then the force has got a particular, what do you call, criteria, that the force should be acting exactly at 90 degrees to the surface. The force should be acting means if a force was acting at say an oblique plane, something like 30 or 60, you will not use that force to calculate pressure. Therefore, the real definition of pressure is when a force acts vertically on a surface, we call it as thrust. Have you understood? Thrust. So in layman's language, you will find that in books they write pressure is the ratio of force upon area. But if you want to make it very correct, then it is the ratio of thrust upon area. And what is thrust? Thrust is the perpendicular force acting on the concerned area. Why do you need pressure? Because it gives you a way to understand the impact of force. Now, if I say that a force of 5 Newton is striking your face, you exactly don't know what is the effect of that. So a 5 Newton can come to you, right, like a palm. 5 Newton can come like a poke. 5 Newton can come with a this much big cricket ball. For everything, the impact is different. Don't you feel so? Or 5 Newton can come with a bullet also. So to understand the effect of force or the impact of force, the concept of pressure is taken. Pressure is thrust upon area. Hamesha yaad rakho, thrust. Perpendicular. If you would have wanted to find out what is the pressure on this surface, try to locate the force which is coming and acting on this surface in perpendicular manner. Always the force should be perpendicular, right? So thrust is a type of force. So if we look at the SI unit, so what will be the SI unit? Force is always measured in Newton. Area is measured in meter square. And this unit has been given a name called PA, which stands for Pascal. So can you now define what is 1 Pascal? 1 Pascal is the force, 1 Pascal is the pressure experienced by a unit surface area when a force of 1 Newton acts on it. Unit surface area or a area of 1 meter square. When a force of 1 Newton acts on a surface area of 1 meter square perpendicularly on it, the pressure experienced by the surface area is said to be 1 Pascal. अगर किसी 1 मीटर स्क्वायर एरिया के ऊपर 90 डिग्री से some force comes and acts on it, which is of 1 Newton, then the pressure is said to be 1 Pascal. Is it fine? 1 Pascal is 1 Newton per meter square. Pressure is one quantity beta which has got many different units. Because see, if you go for navy and submarine, they will be using pressure in torr. Like when you go for inflating the car tires in a petrol station, there the pressure is measured in psi. That is FPS unit. Look, in FPS, how will you say? In FPS, force is measured in pound. Area is measured in square inch. So it is called PSI, pound per square inch. The SI unit is Pascal. You are supposed to do. Then in MKS, it is kg force per cm square. So in different, pressure is the only quantity which has got vivid units. Bar is there, atmosphere, bar, atmosphere, torr, then Pascal, then pound per square inch, kg force per cm square. So many different units. But this is one which we will be using more in for working out problems, and pressure is a scalar quantity. Pressure is a scalar quantity. Have you understood this much? This is the mathematical definition of pressure. Looking at this definition, we can say one thing, that pressure is directly proportional to the thrust, when area is constant. These are very nice findings for a lot of examples. And we can also say that pressure is inversely proportional to area when the thrust is kept constant. Let us try and understand these. And the parent definition is what? Pressure is equal to force upon area, where force is nothing but the thrust. Okay. Now, see, what I want to say here is that if you increase the area, the pressure always reduces. A lot of examples are there. School bags, then Amazon people who come with those heavy bags. Sunne se samajh mein aayega. Amazon guys who come with heavy bags. Have you seen their shoulder straps? This wide. Area is more. The load, he will carry the same load, but the area is made more. If that area would have been, that strap would have been made out of, like, say, small noodle strap type of wire se laga dete, that will strip off his shoulder, yes or no? Because the pressure is much more. So school bags are given with wider straps. Look at a tractor. A tractor is a very heavy vehicle. It plies on what? Wetlands. Have you seen the tires of tractor? This wide, so that the pressure reduces. The pressure should reduce. The same weight of the tractor. One of the very fine examples is something like, say, suppose you have bought a new sofa at your home, right? A new sofa has been purchased at your home, and your mother finds you that you are jumping up and down on this sofa. Obviously, you're going to get a bit of scolding, right? That you are going to damage this sofa. Now, imagine a day when you are unwell. And then the same mother tells you, कोई नहीं बेटा, sofa में लेट जाओ, लेट के TV देख के खाना खाओ. है ना? This also your mother is only allowing. Your weight has not reduced, but the area of contact has increased a lot. In this case, the sofa is expected to get a damage like this. Here, some minute this thing will happen. Say for boys, for more examples, suppose it's a up-class teen party. Up-class teen means at 18 years party, Christmas party, and a boy has got a choice to dance with a girl wearing stilettos and with an elephant. They preferably choose the elephant. Why? Because the girl who is wearing stilettos on a Christmas party, her stilettos is something like this. By mistake, if she steps on your foot, the area is very less. But if you look at the elephant, poor little fellow, he's got a big foot on him. Huh? Elephant kuch nahi karega aapko, aaram se. Now, do you understand pressure? A sharp knife cuts faster, because the sharp knife, when you want to cut, what is the comfort of cutting? If you have to cut an onion, then you are applying more and more pressure. But if the knife is very sharp, the contact area is reduced. Understood? Sharp knife has got a less contact. So with the same force, it will go inside. Injection. You can't avoid the injection. The prick will happen. So should you choose a sharp needle or a blunt needle? Many people think, no sir, sharp needle, I'll get more pain. Sharp needle. More sharp, more better. It will immediately get inside. Imagine giving an injection with a screwdriver. The pain will be more. So have you understood this particular? So whenever you are drawing or any question is coming based on these inferences, use common sense. Okay, a gardener has got a pipe and he has fully opened the tap. That means the water force, the maximum he could get, he has taken it. He still can't water the rose plant. So what he does, he starts putting his finger. So he has reduced the orifice area. So once you reduce the orifice area, पानी और दूर तक जाके छिटकता है, right? Tanks, have you seen tanks have got chain drive, larger surface area, ताकि weight pressure कम हो, नहीं तो tank अंदर धस जाएगा. ये clear हुआ आपको? So on these basis, now just try to think. This is my cuboid. It is not a cube, child. It's a cuboid. Cuboid means the basic funda of a cuboid is the length will not be equal to the, oh sorry, I've used W as the width. So will not be equal to W, which will not be equal to H. They'll have three different. That means if the same force is now given on this cuboid and if I turn it, the pressure will be different, because pressure is force upon area. Right now we have a larger rectangle, so the pressure is expected to be less. If you make this area, just turn it up like this, this area is usually less, so the pressure will jack up. Is this much being understood? Okay, so based on that, the first sort of problems we get those only. Let's look. So you have got, do you have your books with you by any chance? टेक्स्ट बुक निकाल लो बेटा, तो प्रॉब्लम करने में इजी होता है. Same, so you've got your workbook. Okay, so we have see, the first problem talks you about the different way the cuboid, it's page number 79, 79 on your right side. Okay, if you look at this, we'll not spend so much time on the problem now. Just to understand this problem, the cuboid has been put up on two different orientations. Have you seen? 79 top, if you see that problem. The cuboid has been put up on two different orientations. Be careful, okay? On two different orientation. One is in which it has been kept flat, and one it has been kept vertical. So you just need to calculate the pressure in both cases. So while solving these problems, keep one thing in your mind, that if you're reporting your answer in Pascal, your force should be in Newton and your area should be in meter square. So three ways they will trick you in this problem. One is change the unit of force to some dyne, and meter square maybe in centimeter. So take care of the centimeter, take care of the units, and take care of the orientation. And what does the thumb rule say? That if the same force is being exerted upon on a smaller surface area, then the pressure would be more. And if it is on a lesser surface area, rather a greater surface area, the pressure will fall. Is this Gyan understood? Can we go to the next part? Kirtan, any doubt on this part? Dhruv, क्या हो गया? आ नहीं रहा है? बीमार है क्या? कल भी लास्ट 2 क्लास नहीं आया. So is this okay? Introduction part of pressure? Okay, चलो तो आगे चलते हैं. Right. Now, the next thing that we talk about is liquid pressure. Liquid pressure, and we will see some derivations also, because as you see them, then your idea becomes clear. Liquid pressure. Now, if you have a liquid in a container, okay, let's say this is a container, and we have liquid inside it. Yahan concept bahut important hai, so pay attention. And you have liquid inside this container. So liquids exert pressure in all directions. It's not that it will exert pressure. It's in a cylindrical container. I've got some liquid. This liquid will exert pressure, equal pressure. Not first of all equal, it will exert pressure in all directions. That's why whenever there is a pipeline leakage, water pipeline leakage, you will see water coming out in a spider format. All sides the water will come out. Okay? At a particular level, okay, let's say this is at this level, this is a concentric part. At this level, and let's say I have liquid till here. Now, please understand, children, what I have drawn is actually a cross-sectional part. Have you understood? ऊपर से देख रहे हो तो एक cross section. You're seeing a circle. At this level, the pressure at all points will be same. PA, PB, PC, all of them will be same. The pressure at all points on the same horizontal is always same, right? So if this is a horizontal, then pressure here, all the points here will have the same pressure. ये याद रखिए. So pressure at a same level is same at all points. Children, we are learning about, just now what you learned was solid pressure, now you are learning about liquid pressure. All liquids exert pressure, and liquids exert pressure, liquid pressure is exerted in all directions. Exerted in all directions. Have we understood these two? These are some important things, okay? Got it? So in liquid pressure, we see variation of pressure with depth, or we say height of liquid column, height of liquid column. इसको समझने की कोशिश करते हैं कि ये है क्या. Variation of pressure with depth or height of liquid column means as you go down the liquid, what is the impact of pressure, right? ठीक है, आइए इसको देखते हैं. So this is also very nice derivation. You'll understand it. Let's say the takeaway is more important here also. So I have a cylindrical vessel, and in this cylindrical vessel, let's say I have liquid till this level. Right, I have liquid till this level. Right, and I have fixed up a point. Let's say I want to find out that at this point P, how much is the pressure that you expect at this point P, right? How much is the pressure at this point P, and the depth or the height of the liquid column above P is, say, H. Have you understood? Height of liquid column means how much liquid is above this point P. ठीक है, समझने की कोशिश कीजिए. So what we do here, I have arbitrarily, just try and understand, I have arbitrarily thought of a column of water, a cylindrical column of water. ठीक है, ऐसा. Let me finish the drawing, then you will understand what I have done. I have arbitrarily assumed a cylindrical column. Are you able to understand? This is an imaginary column right above this point. Now pressure at all points on this particular cross section will be same based on this, right? So what is this column has been imagined in such a way that, let us say that the cross sectional area of this column is A square units. It can be A meter square, centimeter square, whatever it is, right? Now what is the height? The height is equal to H units. Do you understand? H units. So basically I have a cylinder whose cross sectional area is how much? A. Height is A. Sorry, height is H. I could have also imagined a cuboid. See, I am inside water right now. So I am feeling some pressure on my head. I want to find out how much is this pressure. So what have I imagined? I have imagined that let there be a cylinder or a cuboid column above my head. What should be the height? So that it reaches the top surface of the liquid. Now you will say, sir, why did you not consider the complete cylinder? Why did you not consider a cuboid? You will see that that does not make any great change. आप ये भी बोल सकते हो, सर आपने इतना ही क्यों चूज किया? Did I mention anything about R out here? No. So you can say that this cylinder may be this much big, this much more wide. It doesn't make a sense. You will it doesn't impact at all. You will see that. So what is important for me is the cross sectional area. Understood? Right? So I go by my usual definition. Pressure is equal to force upon area. Yes or no? Yes. Now what is the force that this particular point P is experiencing the force which is equal to the weight of this liquid column. It is experiencing a force which is equal to the weight of this liquid column. Don't you agree? Right? This liquid column must be exerting a low weight W. That is the force. Yes or no? So force is equal to weight of the liquid column upon area. Do we agree? Fine. What is the definition of weight? The mass of the liquid column multiplied by the acceleration due to gravity upon area. Fine. A we know, we have assumed, but we still don't know because A is arbitrary. G we know. Now we need to work about on mass. अच्छा चलो. जरा volume देखो तो what is the volume of the liquid column? Volume of the liquid column is equal to the volume of the cylinder that I have assumed. Children, you could have also assumed a cuboid. It doesn't make any difference. It's equal to the volume of the cylinder. I'm just saying volume. Volume of the cylinder क्या है? Don't use pi r square h. We will use A into h. Cross-sectional area. Disk. How many? H disk. Any symmetrical object, the volume is always cross-sectional area multiplied by the height. Cuboid के लिए क्या था? Length into breadth multiplied by height. समझ में आ गया? तो ये हो गया आपका volume. अच्छा, but we need to arrive at mass, beta. We need to arrive at mass. You have calculated volume. Is there a quantity that connects volume and mass? Density. Yes or no? So let's come to density. Density means this is the density of the liquid. ठीक है ना? Density is equal to what? Mass per unit volume. देखो अगर आपका concept clear है, आप any answer you can answer is mass per unit volume. I am interested in the mass only. So what is mass equal to? M. Mass should be equal to, density is denoted by rho. Rho times the volume. Volume is what? AH. ठीक है? अब इसको यहाँ पे punch कर दें. Shall we punch it here? So pressure becomes equals to rho AHG divided by A. Now A strikes out A. Didn't I tell you the A has nothing to do? This is a very, very important relation. Pressure is equal to rho times G times H. Let us try and understand this first, okay? Look at the three quantities out here. What is this quantity? Density. Whose density? Density of the liquid that you are using. Isn't it not constant? Yes, it will be constant. If you are using mercury, it has a constant density. If you are using water, then the density is 1000 kg per meter cube. If you are using oil, the density. Don't you think G is also constant? This is acceleration due to gravity. Isn't it not constant? Yes, constant. So I am now taking pressure equal to some big constant K times H. Both are constant, na? So can I write pressure is directly proportional to H? This is a big finding. In liquids, as you go down the depth, H means the liquid height above you, or it can also say this is the depth. As you go down in a liquid, pressure increases. That's why everybody can't go and reach the Titanic. You can't go. Submarines 500, 600 meters के बाद जाने के बाद extreme pressure आना शुरू हो जाता है. You can't expect a submarine to go 3 kilometers. Crash हो जाएगा वो. It will be crushed. Therefore, those remote vessels which go to see the Titanic wreck, the viewing glass itself is 40 inches thick. 40 inches means, can you understand? This is 12 inches. 40 inches thick. 12, 3, 36. 4 times of this. That much thick. Otherwise, it will be just crumbled. And you can't go inside. That's what they tried to go. जो explosion हो गया था. Implosion. That was not explosion. Implosion. अंदर से some problem happened and the water pressure. So pressure always increases with depth. This is where in liquids. That is the reason that if you see the walls of dams or the bridge piers which are below in water, the walls of dams and bridge piers are made in such a way that they are always thicker at the bottom. And this is the water level. ये आपका वाटर है। ये क्वेश्चन पूछ लेता है, सीबीएसई में भी पूछता है। सो व्हाई इज दिस मेड थिकर? बिकॉज सर एज यू गो डाउन, as H increases, pressure. And in fact, so many findings you can do. See, one of the very interesting finding that we can do here is, have you seen patients? Patient है ना? ये patient है. The patient is lying down. You need to give an IV fluid to this patient right now. IV. So how is an IV given? You puncture the vein and you just, that's why called intravenous. You will puncture and you will allow the medicine to go inside. So if you puncture, the blood inside it is having, inside you has, inside the vein is having a lot of pressure. Puncture करते ही blood pressure बाहर आ जाता है, because the blood pressure is more than the atmospheric pressure. So the blood is ready to ooze out, but you want the medicine to go inside. That means the medicine has to defeat the blood pressure. So what do the hospitals do? They will always have a stand out here and they will hang your IV fluid out here, number one. And then whenever the IV is given, it will be given here, and with the needle they'll make a puncture out here. They'll puncture the bag. I don't know whether you've seen or not. Whenever an IV is given, the bag will always be punctured. Needle ghusa dega, because from here atmospheric pressure will start pushing it. So what is the pressure? The pressure, the IV fluid pressure has to be greater than the blood pressure. Yes or no? IV fluid pressure will be rho times G times H. Every patient does not suck IV fluid at the same height. So sometimes you'll see swelling has happened. Patient is unable to take the IV. Sister will come and increase. That's the only thing she can do. She has to, because G she can't play with. Rho is the density of the medicine. You can't play with. So either you lower the patient down or you increase the IV bag. That's why this particular stand will always have an adjustment screw. Next time when you have gone to a hospital and you are seeing anyone, be like a science student. Isko dekho. But when you donate blood, where is the blood bag kept? Right down. Because the blood pressure is anyway more. Puncture करते ही blood निकल के आ जाएगा. उसको ऊपर उठाने के. People say no, it should be away from the side. The patient might get frightened. ऐसा कुछ नहीं है. जितना नीचे रखेगा, उतना quickly blood निकलेगा. Therefore, when there's a cut or something, they ask you to raise your leg. नीचे करोगे तो, suppose fractures and everything, when fracture happens, they always will tell you not to put your hand down. The more the blood goes down, pain और बढ़ेगा, swelling होगा. ऊपर रखिए. ये clear हुआ? Pressure increases with depth. इसके ऊपर बच्चा बहुत सारा questions आता है. Why do you think that walls of dams are made thicker at the bottom? So this formula you should know. Pressure is equal to density multiplied by acceleration due to gravity. Density किसमें होगा? kg per meter cube. Acceleration due to gravity, meter per second square. Height will be in meter. Ultimately, this will have the same unit. You want to check? See, as students of science, you should always check. You should check whether this particular equation is correct or not. Can I rub this portion? Let's check. हमेशा check किया करो. What was the first definition you studied? Pressure is equal to force upon area. What is force, beta? Newton. Newton per meter square. What is Newton? Kg meter per second square multiplied by meter square. So this. So basically it is nothing but kg second square meter. Yes or no? जरा उसको check करते हैं. Pressure is equal to rho gh. Rho is in kg per meter cube. G is in meter per second square. Height is in meter. So meter, cube gone and cube gone. And second square remaining. So it is kg second square meter. Both are same. Correct है. ऐसे check क्या करो? आप correct हो कि नहीं? Units have to tally ना. Did you understand what I did? I actually checked the end units for both the expression. That is also correct. That is also correct. ठीक है? ये एक चीज जान के रखिए. थोड़ा सा atmospheric pressure के ऊपर भी जान लेते हैं. You want to note it down? Please note it down. Pressure increases with depth. और उसको जानने के लिए this is the derivation. How pressure increases with depth. This height, this is liquid pressure. Remember, huh? This height is always height of the liquid column above you or the depth at which you are. And if some question comes that at a same level in a liquid, pressure is always same. PA will be equal to PB equal to PC. Okay, one more example that the book gives, which I forgot to show you. Have you seen a badminton shuttle pack? New shuttle pack of badminton is something like a cylinder like this ना, ऐसा कर लो, ठीक है, और इसमें छोटे छोटे होल्स कर लो, plug them and fill this with water and have some mechanism that you can actually open all the plugs at the same time. You will see this one will pour water here, this one here, this one here, नीचे वाला सबसे. Pressure increases with depth. This one is at the maximum depth, so the pressure of ejection will be maximum out here. Fine. Done. Can I rub, or are you noting down as you should? If you can tell me, because there is communication is something that lacks in this class. So please tell me when you are done. Done. Good. आपको ये सब इंटरेस्टिंग नहीं लगता है? क्यों होता है प्रेशर? क्यों लोग टाइटैनिक नीचे? How far is the Titanic? 11 kilometers down in Atlantic. Why do people can't go and catch the wreck? Why can't the wreck be pulled up? What happens when we go down? कितना कुछ इंटरेस्टिंग है. कोई क्वेश्चंस नहीं आते आप लोगों के. लेफ्ट साइड मिटा लो बेटा. Okay. We'll visit liquid pressure once again, though absolutely not covered, but थोड़ा देख लो. Atmospheric pressure. So if this is Earth, so up to some layer 5,000 kilometers तक ये जो है ना, इसको हम क्या बोलते हैं? The layer of atmosphere. So what is there in this layer? Air is there in this layer, right? You have air out here. यहाँ पे air है, ठीक है? So the pressure exerted by the air column in the atmosphere is called atmospheric pressure, right? So let's imagine that there is a person out here. So the person must be experiencing a pressure due to the air column above him. Now, the particles of air are more concentrated. You have more particles when you are near to the earth. As you go higher and higher, air becomes thinner. Air becomes thinner. But if you see at this level, you have more particles. So the air column creates atmospheric pressure. Okay, this is number one. And number two, as the height increases, the air is thinner. So if the air is thinner, it means what? It means less of air particles. Clear or not, bacha? As you're going higher, the air is thinner, less of air particles. So definitely, if you see at this level, say this is height h1 and this is height h2, we will say you have more particles at h2 than at h1. Don't you agree that? All right. Therefore, the
what's the first point?
First point means I didn't get you. Come again. The column, air column creates pressure. Air above you is creating pressure, and the air is getting thinner as we are going up and up. So we've taken two height. One height is say h2 and one height is h1. At h2, I have got more air particles. At H1, I have got lesser air particles. Therefore, the pressure at H2 will always be greater than the pressure at H1. Now, what is this pressure? This is atmospheric pressure, which means in the case of atmospheric pressure, as height increases, atmospheric pressure decreases. लिक्विड के साथ उल्टा है, लिक्विड में जितना नीचे जाओगे प्रेशर बढ़ेगा, यहां जितना ऊपर जाओगे प्रेशर घटेगा. हैव यू अंडरस्टूड दिस कॉन्सेप्ट और नॉट? व्हाई डज द हाँ तो वही तो समझाया ना. व्हाट इज द एटमॉस्फेरिक प्रेशर ड्यू टू? द atmospheric pressure means right now the pressure on my head, there is a pressure we say of 1 atmosphere on my head. How big is 1 atmosphere? If you make it 2 atmosphere, this bone will break immediately. ये जो bone है ना, hang करने से, आदमी को फांसी देने से जो होता है ना, this bone will break immediately. So much is 1 atmosphere. Your head is bearing 1 atmosphere. So this pressure is due to what? This pressure is due to the air column above my head. So if I go more and more high, the air becomes thinner. Thinner means the air particles reduce. So if the air particles reduce, the air column's pressure is also getting reduced. Agreed? Therefore, we say as height increases, pressure decreases. क्योंकि इस यहाँ पे देखो, यहाँ सबसे ज्यादा एयर है, यहाँ ऊपर जाते जाते एयर बहुत हल्का हो गया. तो जैसे जैसे आप अर्थ से हाइट में जाना शुरू करोगे, एयर पार्टिकल्स घटता जाता है, तो आपका एयर प्रेशर घटता जाएगा. Is it understood now?
Yes, sir.
Okay, so I'm just rubbing this example now. So try and understand one more nice phenomenon. Say you have gone for a trekking and you are at a mountain top now. ऐसे आप mountain top में चले गए ना. So out here the height say is H1 and this is your ground level height HGL. Is this height more or not? Yes. So here the air is thin. यहाँ पे air क्या है? Thin है. एयर थिन होने के लिए क्या हो जाता है? Here the air pressure is less, so here the pressure falls. यहाँ पे प्रेशर गिर जाता है. That's why you carry oxygen cylinders and other things. You will feel problem to breathe out here. Okay, now let's see a common example. At the ground level, what is happening? This is you, right? This is you. I have taken a small portion of your hand and I have magnified it. This is your artery. This is your artery. I've just magnified this portion. Okay, I have magnified this portion. This is your artery. What is running in your artery? Blood is running in your artery, right? Isn't the blood exerting pressure on your artery walls? Yes, the blood is exerting a lot of pressure on your artery walls. What is balancing this pressure? The atmospheric pressure is also acting at ground level. So the atmospheric pressure is balancing my blood pressure. जैसे मैं ऊपर चला गया, I have gone on top now. Something got reduced. What got reduced? ऊपर चलते हैं. Now let's look at the same artery. ऊपर चले गए. Now blood pressure is actually exerting pressure. लेकिन ऊपर जाते ही क्या हो गया? Atmospheric pressure कम हो गया है. अब क्या होगा? This blood vessel will rupture. फटेगा. इसीलिए nose bleeding होना शुरू होता है. कान से bleeding होना शुरू हो जाएगा. And people who have got weak tissues, bleeding होना start होगा. In fact, lot of people have got these expeditions. They drive with their car and go to जैसे Tibet चले गए drive करके. So what do? In car, all of us carry something. What is that? Wafers, Lays, chips and all. So Lays लेके आप चले तो गए ऊपर. Once you reach Tibet, if you see these videos, all those Lays packets ना ठाप करके फटना शुरू हो जाएगा. Because the Lays packet has got nitrogen inside it. This is the Lays packet when it is on the ground. Nitrogen pressure is balanced by atmospheric pressure. When you go on top, it's only the atmospheric pressure. And it starts winning the battle. Sorry, it is only the nitrogen pressure which is winning the battle. No atmospheric pressure. Like a pillow it will become. And that was your question. The other question that you had asked yesterday, Sahasra. A person takes a water bottle and then he drinks all the water out here. तो पर्सन ने वाटर पी लिया. अब उसका बॉटल कैसा है? एम्प्टी. Whenever the water bottle becomes empty, what goes inside? Air goes inside. But you unfortunately do not have that much air on top. तो आपके वाटर बॉटल में वहां तो कुछ चेंज नहीं आएगा, एयर घुसा नहीं. But once you come down, you are coming down to a region where air pressure is more. तो जैसे ही आप नीचे आ जाओगे आपका वाटर बॉटल ऐसे पिचकू हो जाएगा. Air has crushed it because अंदर air नहीं है ना, बाहर air pressure है. Have you understood? Atmospheric pressure. So what is the atmospheric pressure? We say the atmospheric pressure is always said to be 1 atmosphere pressure. This is also 1 unit. This is equal to 760 mm of mercury. This is what is actually measured in your clinical measurements also. 760 mm of mercury. It means, what does this mean? It means take a pan of mercury, understand, and take a tube filled with mercury. एक ट्यूब ले लो जिसको मर्क्यूरी से भर दो, भर के उसका मुंह ऐसे बंद करके इसमें उल्टा करके फिर अपना उंगली छोड़ो. Very interesting. Okay, this is already filled with mercury. Inside it, release one inverted tube of mercury. So what is happening? These are all the atmospheric pressure. Atmospheric pressure दबा रहा है mercury को, so mercury should climb. Mercury climbs only up to 760 mm. कैसा भी कर लो, and this portion which is there, that is vacuum. This is atmospheric pressure measurement. This was done by Torricelli ने किया था, Evangelista Torricelli. Therefore he has one unit in his name called torr. Torr भी एक unit है. Bar is also a unit. Pascal is one unit. So many units are there. Is atmospheric pressure clear? Atmospheric pressure always increases as you come down. As you go up, what is the name of the pressure? Atmospheric pressure. अरे ससुरा एटमॉस्फेयर ही नहीं रहेगा तो प्रेशर कहां से आएगा? Atmosphere is more concentrated as you are near to Earth. If you go higher and higher, that's why when an aircraft flies, the first job the first officer has to do after takeoff is pressurize the cabin. If the pilot forgets to pressurize the cabin in an aircraft, immediately oxygen mask will be deployed and people will have giddiness and you will start nose bleeding. Very common, hota hai. It happens on flights. It is not nothing great. And if there is a pressure mismatch, that's why sometimes many people say today landing was not okay or takeoff was not okay. Whenever the takeoff happens, if the pressure balancing has not been done, once the flight takes off, you'll have a minor giddiness. I don't know how many of you feel it. It can be felt. थोड़ा सा puking जैसा आ जाता है. That's because on that flight pressure imbalance है. The flight climbs very quickly to a higher height. वहाँ pressure नहीं है. So the cabin has to be pressurized. Aircraft is always a pressurized cabin. So if you open the door, immediately you will fly out. Is this thing clear? One more concept we have to study. Can I rub this or do you want to note down anything?
So when you place the inverter, won't there already be
No, you will fill it completely with mercury. So there's no air. Completely filled mercury is actually put inside. That's how we do it. This is called our atmospheric pressure is measured. This is called a barometer setup. This is a barometer. There are many other ways also in which we measure pressure, like manometers. Manometers आपको उतना cover नहीं किया है. A manometer is the most common manometer we have is called a U-tube manometer. U-tube manometer कैसा होता है? ऐसा होता है. Say suppose a U-tube like this, right? And say suppose you want to measure gas pressure of a pipeline. So we'll connect it with the gas pipeline. And a liquid will be actually kept in this manometer. यहाँ पे एक liquid रख देगा. Very easy. ये engineering first year में सिखाते हैं. ये liquid रख देगा. How do you measure the gas pressure? So there is a gas pipeline which has a gas pressure called PG. So what will happen? The gas will exert the pressure and this liquid will be dancing up and down. At some level, this liquid will get balanced, right? The level at which it balances, after that you take out the height. ये height कितना है? Pressure on both sides should be equal. So what is the pressure on this side? The pressure on this side is equal to rho times G into this height H1 what other pressure is acting on it? This will be kept open. So you will have atmospheric pressure also. So add atmospheric pressure this side. What is the pressure on this side? Sir, the pressure of the gas plus the height of the liquid column out here. So it will be rho g H2. You can measure everything, so you can find out what is the gas pressure using a U-tube manometer. This is known as a manometer. This is in your further read section if you are interested. So this is called a U-tube manometer. A U-tube manometer is the simplest device with which we can measure pressure. Have you understood the logic? Pressure of the gas will push this liquid and the liquid will dance out this side and somewhere it will get settled. Once it has got settled, record this height, record this height. So what is the pressure on this side? Pressure due to the liquid column, which we had studied, rho gh, plus the atmospheric pressure. And on this side, it's not open, so there's no atmospheric pressure. ठीक है? तो ये भी हम देख सकते हैं. This is only for further reads. ये आपको आता नहीं है. ये वाला concept clear हो गया? And now we see two applications of liquid pressure. Jack. Hydraulic jack. Hydraulic jack and hydraulic brakes. So what is a jack? A jack is a device which we use to lift heavier loads using lesser effort. कम effort से heavy चीज उठाना है. If you go for a puncture repair or something, a lean and thin guy will come. He just puts the jack, टक 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 ऐसे मारता है, पूरा गाड़ी उठ जाता है. उसका उतना ताकत ही नहीं है ना? Machine है. In a machine, the first job is a machine should give you mechanical advantage. Effort should be less. If you are putting more effort, then you have designed an idiotic machine. Yes or no? A machine should have less effort. More should be the mechanical advantage. तो hydraulic jack में हम लोग क्या करते हैं? मान लीजिए यहाँ पे you have a very simple mechanism. Let this cross-sectional area be A. What is this cross-sectional area? Capital A. Capital A ज़्यादा बड़ा है, ठीक है ना? This is more. And on this, let us put a platform on this. We keep a platform, और इस platform में हम हमारे गाड़ी को ले आते हैं. A car is kept here. And here we would be keeping what? Liquid. So we will keep liquid out here. So liquid rag do. So till this level we'll have liquid. And this bar is connected to a piston. This is a piston. It can go up and go down. And here also what we will do, we will have a piston. ठीक है ना? और ऐसा piston दे दिया. So what do? You are giving a force downwards. आपने force दे दिया है यहाँ पे. देखो यहाँ पे force दिया. Force देते क्या हो गया है? This piston is pushing this liquid down. ठीक है ना? So what is the pressure that you expect out here? The pressure here will be F upon A. Now liquids, what did we study? Liquids cannot be compressed. ये liquid को take a syringe, fill some water in it, and close the head of the syringe and try to push the plunger. कभी push ही नहीं होगा. Liquid cannot be compressed. अब ये liquid compress नहीं हो पाएगा. तो इसके इस side में क्या हो रहा है? It is sensing a lot of pressure because you have put pressure out here. So it transmits the pressure across the whole liquid. So what does this liquid do? This liquid has no other option but to raise this piston. So what is the pressure? So it will actually create, the pressure here should be same as the pressure here. So let this be A, let this area be A. So, and let here the pressure be, say this be P2. So tell me what is the pressure P2? This is say P1. P1 is equal to F upon A. P2 will be equal to P1 because liquid cannot be compressed. So P2 equal to P1 means P2 is also equal to how much? F upon A. And as such P2 will be equal to how much? The force that you can generate here due to the cross section. Now play between these ratios and you can increase F as you want. आपको जितना F चाहिए आप निकाल सकते हैं. छोटे एरिया में ज्यादा प्रेशर देंगे तो प्रेशर बढ़ गया. सेम प्रेशर is now given over more area. So we get less force. Jitna force chahiye, that is sufficient to lift the car. The car upar aa jata. Have you understood this concept? The basic is liquid cannot be compressed. So we play between the orifice sizes and put liquid. Brakes. Another application is brake. So in brakes, what happens? This is suppose this is the brake pedal, and this brake pedal is actually pressed by you. ये आपका जूता है और आप इस brake pedal को press करते हो. You press the brake pedal. Once you press the brake pedal, you actually have, the car has something called brake oil. Car में, a car, you know how many fluids a car has? It needs fuel to run, petrol. Then a car has something called coolant, which cools the car. Then a car has got power steering fluid. A car has got transmission oil, which runs the engine. A car has got engine oil. A car has got brake oil, and a car also has a windscreen washer. 6 different type of fluids are there working in the car. We are on the brake oil. So the brake oil will be now going to something which is known as a master cylinder. This is the master cylinder. Your book will have a better diagram. So when you press the brake, brakes are what, beta? Self-energizing. Whenever we press a brake, doesn't the brake come back? Yes, it has to come back. It's not self-locking. This you learn in engineering. This is called self-energizing. How about a jack? A jack is self-locking. If you lift a jack and then it is self-energizing, तो jack फिर नीचे गिर जाएगा ना. Jack को कभी भी self-energize नहीं करना है. Jack should be self-locking. Brake should be self-energizing. वरना ब्रेक मारा तो ब्रेक लगा ही रहेगा गाड़ी में गैं करके, ऐसा तो नहीं होता है. The brake should release itself. So you press the master cylinder. So what happens? This master cylinder will now press the brake oil, and this master cylinder is connected with 4 pipes, 2 on the front left, front right, and 2 here, rear left, rear right. Every wheel, now let's go to every wheel. In every wheel there will be 2 pistons on either side. ऐसे फिर 2 piston रहेगा. So how many pistons you have? 8 pistons. 4 wheels, 8 pistons. You press this pedal, the liquid gets compressed here, and this compressed liquid sends signal to all the 4. चारों को मारेगा. So this one gets pressed this side, this one gets pressed this side. Now what does this pressing do? It then goes to the, what you call, this is called the brake drum. Brake drum is the portion which rotates with your wheel. Then you will have something called a brake shoe. ठीक है? और finally इसके बीच में ऐसा करके एक स्प्रिंग रहेगा. जैसे ये प्रेशर आता है, ये प्रेशर इस साइड में आएगा दोनों. So it will allow both the brake shoes को इस साइड में धकेलेगा. It will push the brake shoe. This portion is rotating. This portion is rotating. So the brake shoe goes and just hits the rotating brake drum, stops the car. And when you release it, what have you done? To go this side, you must work against the spring. The spring expands. So when you release the brake, the spring contracts. That's how this pedal again goes up. ये spring बहुत important है. If the spring was not there, the brake shoe would have always been attached to the brake drum itself. See, when you engage something, there should be a mechanism of retract also. This retract is done by this spring. So imagine if we increase our pressure, when you're pressing the brake pedal, the master cylinder's piston is squeezing the brake fluid, and it is actually squeezing 8 pistons, 2 per wheel, and those pistons are actually pushing this brake shoe on the rotating. ये drum घूम रहा है. This is connected to your wheel, और ये कचाक करके जाके लगा देता है. That's why they say after some time your brake shoe wears down. This is your brake shoe, and it will wear down because the abrasive surface is gone. And as it goes and catches the brake drum, it works against the spring. It elongates the spring. Once you release the brake from your foot, the spring again wants to contract. That's the natural tendency. That's how braking happens. Again, hydraulic. Action of hydraulic pressure. Did you understand the concept of jack and brake? Jack के ऊपर आपको problems आएंगे. All problems will be these only connecting. Yeah, बोलो.
Usually left forward cut like saying for any engages moving forward to minus interaction sign. The surface area is better.
आपका voice थोड़ा disturbing है. धीरे धीरे बोलो बेटा.
Sir, jack for दूसरे side रहेगा NS large.
हाँ,
Is that because the force would also need to increase to have the same pressure?
एक्चुअली क्या होता है, लार्जर तो इधर करना ही पड़ेगा क्योंकि यहाँ पे आपको बड़ा वेट लाना है ना. But you need a force which should be sufficient enough to lift it. That's all.
Yeah.
This force is what is your applied force.
Yes, sir.
And ये applied force को भी हम हाथ से इतना क्रिएट नहीं करते हैं, इसको भी और एक जैक के साथ कनेक्ट करके रखेंगे. Are you understanding? You can amplify the forces also, na?
Okay.
Have another hydraulic system. You will see somebody just pumping the hydraulic system and then this pressure will be created. Maybe हाथ से आप इतना pressure create ही नहीं कर सकते. So they will switch on a pumping machine and that pumping machine will start compressing this liquid. And as the liquid gets compressed, this pressure is transmitted to this side. Now you play on the ratios. आपको कितना उठाना है उस हिसाब से डिजाइन कीजिए अपने जैक को. End of the day, this pressure can be transmitted to this side. As simple as that. Right? And ये ऐसा नहीं रहता है. There is another diagram in your book which they will show. There is a reservoir. Reservoir रहेगा, plunger रहेगा, and there will be two valves. Suppose आपको गाड़ी उतारना है, you want to bring down the car, then what will you do? If you want to bring down the car, then they will release the pressure from this side. The liquid will again travel this side. ये ऊपर उठ जाएगा and the car नीचे है. गाड़ी को तो नीचे भी उतारना है ना? After your repair work is done, the car is to come down. How do you bring the car? So this is completely energized and locked. And then you will see suddenly they will release the करके आवाज करेगा. Pneumatic भी होते हैं, not always hydraulic. In car stations and all, it's not. There are pneumatic also. Pneumatic means with air they are lifting your. Hydraulic things are seen in. Have you seen some almari and lofts? When you open the loft or bed, they will say our bed is very costly because it has got a hydraulic lift. It will not make any noise at all. ऐसे खोल दो आराम से, like the boot space of a car, SUVs and all, it just opens up. Have you seen? So when the boot space of a car opens up, on both sides you will see two hydraulic pistons. Those are very delicate. Many people they just bam करके दरवाजा बंद, डिक्की बंद करता है. Now, soft release ones will open very आराम से खुलेगा, आराम से जाएगा. Fine. This was the concept of pressure. There is nothing more apart from this in your chapter. Are we fine to do problems now? थोड़ा सा problems करते हैं. ठीक है, चलिए. So let's do a jack type problem, cuboid type problem. आओ, एक jack type problem करते हैं. Then you can also. So let's take a problem. See, a hydraulic jack is used to lift a heavy load. I'm on page number 80, left hand side, right bottom. A hydraulic jack is used to lift a heavy load. Force of 1 Newton is applied to a piston area. जरा देखो तो कितना है? You are applying a force. How much force are you applying? Let's say the force you are applying is 1 Newton, and you are applying it to an area of how much? 0.01 meter square, if I'm not wrong. Is it 0.01? Yeah, 0. The pressure is transmitted through the liquid. This is the application side. This is the application side. ये आप डाल रहे हो. So obviously this will create a pressure, है ना? And this pressure is transmitted because it is hydraulic. So the pressure is transmitted to your output side. Now let's see what is happening on our output side. It is transmitted to your output side to a second piston whose area is 0.5 meter square. Output side का जो हमारा area है A2, that is equal to 0.5 meter square. है ना? ध्रुव समझा अभी? ये आउटपुट साइड में गया 0.5. हमें पूछा है कैलकुलेट द लोड दैट यू कैन लिफ्ट. अब आप कितना लोड यहां उठा सकते हो, राइट? हाउ मच लोड यू कैन लिफ्ट. सो द लोड विल बी नथिंग बट इक्वल टू द फोर्स ऑन दिस साइड व्हिच इज इक्वल टू F2. yes or no? If the load is 5 kg, 5 Newton, the force should also be 5 Newton. So whatever force you will get is the load you can lift. So what is the guiding principle? Pressure on this side should be equal to pressure on this side because a liquid cannot be compressed. है ना? Liquid cannot be compressed. Equate कर दो. What do you get? F1 upon A1 should be equal to F2 upon A2. So your F2 comes equals to F1 by A1 times A2. So many newtons. Calculate कर लीजिए, आपको आपका आंसर मिल जाएगा. ये डेटा दे दिया ना आपको. Try and calculate how much you will get. for this why you need calculator? This is all 1 पे खेल रहे हो, 1.1 0.5 5 न्यूटन 5 न्यूटन गलत होगा, 50 न्यूटन होगा, 50 न्यूटन होगा। कैसे 500? कैलकुलेटर क्यों चाहिए बेटा? आप लोग का कॉन्फिडेंस इतना कम क्यों है? F1 की वैल्यू कितनी है? 1 न्यूटन। एरिया 1 कितना है? 0.01। 0.01 मींस 1 into why 1 by 10? 50 न्यूटन 1 into 10 to the power minus 2। इसका एरिया कितना है? 0.5 मींस 5 into 10 to the power minus 1। बस हो गया। अब करना ही क्या है? Final answer will be 5 into 10 to the power minus 1 plus 2 which is equal to 5 into 10 to the power 1 which is equal to 50 न्यूटन। इसको क्या कैलकुलेटर चाहिए? तो हाथ से हो जाता है। और कैलकुलेटर लेके भी 2 बार गलत बोल रहे हो, एक बार 5 बोल रहे हो, एक बार 500 बोल रहे हो। Which wrong value? You also took a calculator. Every time why are you dependent? No, you stopped it after I said. Default setting is using a calculator. Look at the problem. It has got 1, 1 and 5. You're only playing with tens and hundreds out here. Why do you need the calculator? अच्छा ठीक है, एक छोटा सा चीज और बता देता हूं before we close so that we can do more problems in our next class. So if you see town water systems and all, how are water systems given? Say suppose you are at a city where houses are at the same level. Same means at ground level के houses हैं। ग्राउंड लेवल के हाउसेस को पानी देने के लिए हम लोग क्या करते हैं? ऐसे एक रिजर्वायर बना लेते हैं ना। सो व्हाट आर यू डूइंग? यू आर यूजिंग द पोटेंशियल एनर्जी ऑफ द वाटर आउट हियर। सो वाटर विल कम एंड कैन इमीडिएटली फीड ऑल दीज हाउसेस। बट हियर यू हैव गॉट अनदर स्काईस्क्रैपर। नाउ यू हैव टू डू वर्क अगेंस्ट ग्रेविटी। पानी तो जाएगा नहीं, सो यू हैव टू पुट अ पंप। द पंप विल टेक वाटर। सी ऑलवेज रिमेंबर एवरीथिंग फ्लोज डाउन अ potential head. Potential head means you have to have a potential difference. That is, if there is a point P1 and another point is at P2, where P1's potential energy is more than P2, then flow will always happen in this direction. This is the universal concept of physics. If this body is at a higher temperature, this is at a lower temperature, heat will always flow. This is called potential gradient. If this body is at a higher charge and this is at a lower charge, current will flow like this. If this person is more rich and this is poor, unfortunately money doesn't go like this. एक human behavior को छोड़ के in every behavior flow is always along the, because this man wants to be more and more rich and if possible he will suck out whatever money this guy also has. So इस side में money flow करना शुरू कर देता है. That is what is injustice, right? So remember one thing, current हो गया, heat हो गया, everything flows down a gradient. Whenever you want to do job opposite to this, outside temperature 40, you want to maintain your room at 20, you want to keep on throwing heat outside, you have to put energy into the system. Air conditioner, refrigerator, inside temperature less, outside temperature more, you're still throwing out temperature. How are you throwing out? Using electricity. Energy spend karna hoga. So here also this thing is same. If the water is at this level and you have to rise it up to a high size skyscraper, पानी उठेगा नहीं ना, तो आपको पंप यूज करना पड़ेगा. So read the chapter once and come to your next class. If you have worksheets, we will do and we will keep these classes till your exam starts for any doubt pertaining to maths, chemistry or physics. But personally, I would say we need to take up some more problems on what you call pressure. So जब आपके पास रहेगा तो आप देख लीजिएगा exam style questions, we can do them. Fine.